Humanity stands at the threshold of an extraordinary moment, a moment that will forever redefine how we perceive the universe and our place within its boundless expanse. For centuries, we have looked upward, wondering what lies beyond the shimmering points of starlight that the night sky. We have built telescopes, charted orbits, and created maps of the heavens long before we understood the profound scale of what surrounded us. Yet despite all our knowledge, one truth continues to drive our curiosity. The universe remains unfathomably vast and breathtakingly mysterious. Landing humans on an asteroid represents a symbolic tearing of the veil, a declaration that we no longer remain confined to the safe cradle of Earth, but are prepared to reach outward toward the unknown. The mission to land humans on the first asteroid will not simply be a scientific undertaking, will be a revolutionary shift in the story of civilization. Early astronomers gazed at wandering lights they called minor planets, never imagining that one day human beings would physically stand on them. They were distant, silent rocks drifting through the void. Today they are gateways to knowledge, storehouses of untouched cosmic history, and potential stepping stones to the outer planets. The first asteroid landing will combine the ambition of lunar exploration with the vast unpredictability of deep space. Unlike the moon, an asteroid is not a stable sphere, but a tumbling relic of creation, low in gravity, rich in secrets, and demanding respect. The science community views this mission not only as a feat of engineering, but as a philosophical gesture. A human presence on an asteroid will place us face to face with primordial material older than any mountain, any ocean, or any continent on Earth. These celestial fragments contain the building blocks of planets and the preserved chemical stories of the early solar system. By studying them directly, with the sensitivity and intuition of human perception, we unlock insights that robotic probes cannot fully capture. The senses of a trained explorer operating on the surface of an asteroid offer an irreplaceable perspective. Every small rock fragment, every texture of dust, every unexpected shimmer under sunlight can reveal a piece of cosmic history. The challenges begin with a strange environment. Unlike Earth or the Moon, an asteroid does not present a welcoming surface with dependable gravity. Instead, it offers an eerie dance between motion and stillness. A human astronaut standing on such a surface might feel almost weightless. A careless push could send one drifting into space. Entire landscapes may shift with the slightest touch. Because of this, the landing will require a complex blend of propulsion control, magnetic anchoring, and microgravity maneuvering. Engineers must design suits that function like flexible personal spacecraft. Rovers must be capable of jumping rather than driving. Stability must be engineered, not found. Yet even amidst these challenges, the opportunity for advancement is unmatched. Asteroids contain metals, rare minerals, and perhaps trapped volatiles that could support future human outposts. Learning how to operate on them will pave the way for resource utilization, which in turn supports deeper missions toward Mars and even beyond. Nothing symbolizes the maturity of a spacefaring species more than the ability to harvest resources from other worlds. The first asteroid mission is therefore a rehearsal for the long future in which humanity becomes an interplanetary civilization. With every step taken across that rugged alien rock, we move closer to a time when humans live, work, and thrive throughout the solar system. Beyond the scientific and technological dimensions, there is a profound psychological element. The first astronauts who set foot on an asteroid will confront an overwhelming solitude. An asteroid is a tiny island adrift in infinite blackness. Standing on its surface may feel like floating in the center of eternity. The horizon is narrow, the world beneath their boots is small, and the stars above appear clearer than anywhere in the solar system. Such an experience will demand emotional resilience, philosophical depth, and an unshakable sense of purpose. These explorers will redefine not only geography, but human identity. They will be the ones who stand between past and future, linking the ancient dreams of humanity with our cosmic destiny. As preparation intensifies, various candidate asteroids come under consideration. Among them, Apophis stands out for its proximity, for its size, for the rare opportunity it presents as it comes close to Earth in the coming decades. The arrival of such a celestial visitor offers a practical testing ground for human exploration. While the scientific debate continues, the vision is unmistakable. The chosen asteroid will become a symbol of courage, curiosity, and evolution. It will become not only a landing site, but the birthplace of a new chapter in our history. The spacecraft designed for the mission will embody decades of accumulated knowledge. It will merge the strength of planetary landers with the precision of orbital maneuvering vehicles. Inside will be a crew carrying not only tools and instruments, but the collective hopes of 8 billion people. The journey itself will be a transformative voyage. As the ship drifts farther from Earth, the blue cradle of humanity will shrink into a pale, shimmering. The astronauts will watch it recede, understanding that for the first time their world is behind them and their destination is a silent, drifting stone ahead. That psychological transition from earthbound to spacefaring will redefine their identities. Upon approach, the asteroid will appear strange, almost fragile. It will look like an ancient, scarred relic of creation. Its surface will be coated with fine regolith, its shape irregular, its shadows sharp and dramatic. The delicate maneuver of matching its slow rotation will require precision beyond any mission before. The landing team will descend onto the surface using thrusters as gentle as breath. Anchoring will be the first major step. Humans will secure themselves using spikes, adhesive systems, or controlled magnetic grips, depending on the composition of the rock. This moment will be unlike the moon landings, which were marked by firm gravity and stability. Here, the astronaut will almost float while touching the surface, a paradox of motion and stillness. The first human step on an asteroid will be an event that echoes across centuries. It will represent the expansion of human existence into the true wilderness of space. The moment will be broadcast globally, but the experience will be deeply personal. The astronaut will gaze across a world so small that its horizon ends only a few meters away. They will look upward and see stars unblinking, clear and ancient. They will feel the crushing absence of atmosphere. In this otherworldly environment, the human spirit will stand in defiance of fear. Humanity will have proven that exploration is not a footnote of history, but a permanent part of who we are. Scientific operations will begin immediately. Drills will penetrate the surface, gently collecting samples from untouched depths. Instruments in human hands will allow immediate interpretation of textures, forms, and structures. Humans will be able to identify unusual patterns that machines might overlook. They will witness ice crystals shimmering in sunlight, ancient layers preserved for billions of years, and grains of dust that predate the Earth itself. Each discovery will feed into a broader understanding of planetary formation. Every moment will deepen our comprehension of how the solar system evolved from chaos into the dynamic environment we see today. As explorers move across the asteroid, they will face challenges unknown on any other celestial body. Each step must be calculated. Tools must remain tethered. Movements must be deliberate. Communication delays will require the crew to think autonomously and trust their extensive training. Yet the sense of independence will be empowering. For the first time, humans will operate in a realm where natural rules differ entirely from those of Earth. They will expand the boundaries of human ability, proving that even the strangest landscapes can be mastered with courage and intellect. The psychological effects of the mission will be profound. The astronauts will experience a rare sense of isolation, but not in a negative sense. It will be a contemplative solitude, a moment where the universe feels overwhelmingly vast and extraordinarily beautiful. Philosophers speak of awe as a transformative emotion. Standing on a small spinning stone suspended in infinite darkness will create awe in its purest form. The crew will return with a deeper understanding of life, purpose, and unity. Their words will inspire future generations to look beyond borders and into the cosmos with hope. The mission will also influence the future of international cooperation. No single nation alone embodies the totality of human aspiration. The first asteroid landing will be a collaborative triumph, shared across cultures and societies. It will remind us that the cosmos does not belong to a single flag, but to all of humanity. Working together will be essential for long-term exploration. The asteroid mission will prove that when nations unite for a purpose greater than themselves, extraordinary achievements follow. As the mission nears completion, the crew will prepare to leave the asteroid. They will carefully lift off using precision thrusters, rising slowly above the rocky surface. The small world that once felt immense during exploration will now appear modest, drifting gently behind them. Yet its significance will be immeasurable. It will stand forever in the collective memory of humanity as the first alien world to welcome a human footprint beyond the moon. It will symbolize courage, curiosity, resilience, and the unending desire to understand our place in the universe. The return journey will be a time of reflection. The astronauts will look back on their experience, realizing that they have witnessed a perspective few in history have ever known. They will bring home samples that contain the ancient memory of the solar system. They will bring stories that inspire millions. They will bring scientific knowledge that propels humanity toward Mars, the outer planets, and perhaps one day the distant reaches of interstellar space. The legacy of the first asteroid we land humans on will be enduring. It will reshape education, technology, culture, and philosophy. Students across the world will study its surface in textbooks. Engineers will use the mission as a foundation for designing future spacecraft. Sociologists will explore the psychological breakthroughs achieved by the crew. Writers, artists, and filmmakers will draw inspiration from the images and emotions captured during the expedition. The asteroid will become a symbol of possibility, showing that limitations are merely invitations to expand our imagination. In the centuries that follow, humanity may look back on this moment as the spark that transformed us into a multi-world civilization. When children on distant planets study their origins, they may learn that everything began with a single asteroid, a single landing, and a handful of explorers who dared to step onto a drifting stone in the silent depths of space. Their bravery will echo across time, reminding us that the universe belongs to those who seek to understand it. And so we stand today at the precipice of that future, ready to choose the path of exploration over hesitation. The first asteroid we land humans on will not merely be a scientific milestone. It will be a testament to the human spirit. It will be a story we tell endlessly. It will be a beginning, not an end. As humanity reflects on the first asteroid landing, it becomes evident that the mission has reshaped not only technological expectations, but cultural narratives across the world. Stories that once belonged solely to science fiction have shifted into the realm of scientific reality. The line between imagination and possibility grows thinner as new generations grow up witnessing events that previous centuries could scarcely conceive. The landing on the asteroid becomes a new reference point for what human ingenuity can achieve. It stands beside the first moon landing and the launch of the earliest satellites as a turning point where humanity proves once again that limitations are temporary obstacles rather than enduring walls. The mission serves as a catalyst for renewed interest in the cosmos. Universities report spikes in applications for astrophysics, planetary science, robotics, and engineering. Children ask questions about asteroids, comets, scattered disk objects, and interstellar visitors. They imagine futures in which they might land on distant moons, explore alien oceans, or help construct the first bases on Mars. Curiosity expands like a cosmic ripple fueled by the images and accounts returned from the asteroid. Textbooks across nations rewrite their chapters on space exploration, integrating this new achievement as a central moment of scientific progress. Philosophers and thinkers find themselves confronted with a broader dimension of meaning. The asteroid landing challenges concepts of identity and belonging. Humans have always defined themselves by the boundaries of the Earth, yet now a fragment of the solar system carries the imprint of human presence. The mission urges societies to reconsider the definition of home. Perhaps home is not a single world, but the entire span of the solar system. Perhaps humanity is entering a new era in which our environment extends far beyond the familiar landscapes of forests, rivers, and cities, and stretches into the silent beauty of celestial rocks drifting around the sun. This shift in perspective also influences the way people view Earth. Seeing astronauts operate on an asteroid gives humanity a fuller appreciation of the fragility of our own planet. Compared to the barren rock of the asteroid, Earth appears as a miraculous oasis of life. Astronauts returning from the mission often speak about the profound emotional impact of seeing Earth from afar. They describe how its colors seem impossibly vivid, its atmosphere like a delicate veil, its oceans shimmering with a vibrancy unmatched by anything in space. These descriptions spread through media and public discourse, inspiring a renewed sense of responsibility to protect the planet that nurtured us. Around the world, organizations and governments start reimagining their long-term strategies. Nations that once competed fiercely in space exploration begin forming new alliances. Scientists share data more openly, engineers collaborate more freely, and international missions gain popularity as the cost and complexity of deep space operations require global unity. The asteroid mission becomes symbolic of this shift, where human aspiration triumphs over geopolitical division. History remembers this mission not just for the landing itself, but for the unprecedented cooperation that made it possible. The scientific impact continues to grow as researchers analyze the samples retrieved from the asteroid. Tiny grains of ancient material hold clues to events long predating Earth's formation. Some grains suggest turbulence in the early solar nebula. Others hint at the presence of water-bearing minerals that could have delivered essential chemical ingredients to early planets. Each discovery adds another puzzle piece to the cosmic timeline, helping scientists reconstruct the processes that shape the planet's moons and smaller bodies. The samples become treasured artifacts stored in special laboratories with conditions carefully controlled to preserve their integrity for future generations. Among these samples lies one particularly interesting find, a fragment that retains a peculiar crystalline structure unlike anything commonly found on Earth. Scientists debate its origin. Some suggest it formed under extreme temperature variations common in the early solar system. Others propose it may be part of a larger mineral type yet to be fully understood. This single discovery sparks numerous publications, conferences, and theories. Once again, the asteroid mission proves that even a small piece of cosmic material can open vast doors of inquiry. The impact on future mission planning becomes even more pronounced when engineers study how well their designs performed. Data collected from astronaut movements, instrument stability, and anchoring mechanisms leads to new designs for next-generation vehicles. Lessons from the mission make future asteroid landings safer, more efficient, and more ambitious. Teams begin conceptualizing larger missions involving extended stays on asteroids, construction of temporary shelters, and eventual resource extraction. The first landing becomes the foundational blueprint upon which many future endeavors will be built. Technological evolution accelerates as industries adopt innovations developed for the mission. Energy-efficient thrusters, lightweight composite materials, and advanced navigation software find applications in terrestrial transportation, renewable energy systems, and robotic infrastructure. Space technology, once reserved for distant futures, begins influencing everyday life on Earth. These developments show how space exploration often brings unexpected benefits to society, creating solutions that reach far beyond their original purpose. Cultural expression undergoes transformation as well. Artists, musicians, and writers draw inspiration from the imagery and emotions of the mission. Paintings capture the stark beauty of the asteroid's terrain. Films portray the psychological experience of standing on a tiny worlds surrounded by infinite darkness. Poems reflect on the courage required to take such monumental steps into the unknown. Literature explores themes of exploration, identity, solitude, and purpose. The asteroid mission becomes a wellspring of creativity, enriching global culture. As the generations progress, people come to view the asteroid landing as a symbol of humanity's transition toward a cosmic civilization. Museums dedicate entire wings to the mission, displaying suits, tools, and replicas. Teachers use the story to encourage students to dream beyond traditional boundaries. Public squares feature sculptures representing the moment of human contact with the asteroid. The landing becomes a shared memory, even among those not yet born at the time of the event. It enters the collective consciousness as a story of ambition and unity. Meanwhile, scientists prepare for next phase missions driven by the wealth of knowledge obtained from the first asteroid landing. Plans emerge for sending crews to larger asteroids with more complex geological histories. Discussions intensify about landing on metallic asteroids that could provide unprecedented resources. Some propose establishing orbiting platforms around certain asteroids to support long-term monitoring and research. The first landing becomes a launch pad for continuous progress, each new mission building on the last. Humanity begins to recognize the strategic value of asteroids in future planetary defense. With direct experience operating on an asteroid, scientists can better understand how to redirect or modify the trajectory of potentially hazardous near-Earth objects. Techniques that once existed only in simulations can now be informed by hands-on knowledge of surface conditions, material strength, and structural composition. Confidence in defending Earth from cosmic threats grows as humanity gains practical experience working on these ancient bodies. Alongside scientific and strategic advancements comes the question of long-term sustainability. Discussions arise about how to manage resources ethically, how to ensure that future missions respect the intrinsic value of celestial objects, and how to prevent overexploitation. Humanity begins shaping early guidelines and philosophies for responsible cosmic stewardship, acknowledging that exploration must be paired with wisdom. These discussions become part of academic curricula and policy frameworks guiding the future of space activity. With each passing year, the story of the asteroid mission evolves from a singular achievement into a defining chapter of human identity. Museums host anniversary celebrations. Space agencies release new documentaries. Astronauts who walked upon the asteroid become mentors for new generations of explorers. Their recollections offer personal insights into the emotional and intellectual significance of the experience. They speak of the silence of space, the surreal sensation of standing on a rock floating in nothingness, and the realization of how extraordinary human imagination can be when paired with determination. People begin to understand that space exploration is not merely a scientific or technological endeavor, but a deeply human one. It embodies curiosity, courage, cooperation, and creativity. It emerges from the simplest questions asked by ancient sky watchers and culminates in the bold actions of astronauts stepping onto distant worlds. The mission to the first asteroid becomes a reminder that knowledge is not static, but constantly expanding. It invites humanity to keep exploring and to never stop questioning. As the narrative of the mission continues to inspire future centuries, the asteroid upon which humans first landed becomes a symbol of progress preserved in history. Images captured by the astronauts circulate endlessly, showing the tiny footprints pressed gently into the dust, the anchored equipment reflecting sunlight, the vast black sky surrounding a small, irregular world. These images give humanity a sense of belonging not just to Earth, but to the cosmos itself. In time, when humans eventually establish bases on Mars, when they explore the moons of Jupiter and Saturn, when they travel to icy comets and drift through the outer regions of the solar system, they will look back at the first asteroid landing as the moment when humanity took its bold first step into the deeper frontier. The mission will be remembered as the turning point when exploration shifted from dream to destiny. And still, the journey will only be beginning. Humanity will continue moving outward, learning, gaining wisdom, and discovering wonders hidden within the cosmic expanse. The first asteroid we landed humans on will forever stand as the spark that ignited the era of true cosmic citizenship. It will remind every future traveler that great futures are built not through caution, but through courage and the willingness to touch the unknown. As the impact of the first asteroid landing continues to ripple across global consciousness, a profound shift begins to occur in how humanity perceives exploration itself. For centuries, exploration meant crossing deserts, oceans, and continents. It meant carving pathways through forests or sailing across uncharted waters. But now exploration has redefined itself as something far greater. It has become the pursuit of understanding in a universe where boundaries extend infinitely outward. The asteroid mission demonstrates that humanity has outgrown the limitations of terrestrial discovery. Our new frontier stretches across millions of kilometers of empty space dotted with worlds that have never felt the touch of human presence until now. This shift influences politics, economics, and education in ways that few could have predicted. Governments begin reshaping their long-term goals around sustainable expansion into space. Funding for cosmic research becomes an investment not only in scientific prestige, but in planetary safety, environmental resilience, and economic opportunity. The knowledge gained from the first asteroid mission creates confidence that future ventures will yield equally valuable insights. As this confidence grows, nations begin entering agreements to share resources and co-develop technology that will support long-range missions. The asteroid becomes a model for cooperation and a testament to what humanity can achieve when united. Universities introduce new fields of study focusing on extraterrestrial geology, microgravity construction, interplanetary habitat design, and deep space psychology. Students aspire to become not only astronauts, but engineers who build asteroid laboratories, or scientists who decode ancient solar system materials, or physicians who specialize in long-duration space health. Academic departments collaborate across subjects, combining ethics with engineering, history with astrophysics, and biology with robotics. The mission inspires a holistic approach to education where human understanding is seen as a collective endeavor. The psychological and spiritual dimensions of the mission continue to evolve as well. Many people begin to feel a sense of cosmic connection, recognizing that Earth is only one part of a vast and interconnected system. Spiritual leaders incorporate images of the asteroid into their teachings, using them to illustrate humility, wonder, and unity. Standing on a world so small that one can see its curvature from only a few steps away evokes powerful questions about existence. The mission encourages millions to reflect on their own lives and consider the broader purpose of humanity within the universe. Museums and cultural institutions preserve artifacts from the mission with great care. The suits worn by the astronauts become iconic symbols of bravery and scientific dedication. The tools used to collect samples become historical treasures. Motion capture holograms recreate the movements of the astronauts on the asteroid, allowing visitors to experience the sensation of walking in a low-gravity environment. Children gather around these displays with wide eyes, imagining themselves as the next explorers to step onto distant worlds. The mission becomes a living story passed from one generation to the next, shaping dreams and ambitions across continents. The media continues to broadcast new discoveries emerging from the samples. One sample contains rare isotopes that help refine models of solar system formation. Another reveals traces of organic molecules, hinting at the chemistry that may have played a role in early planetary development. These findings fuel renewed scientific debates, opening pathways to deeper understanding of how life might arise on planets. Although the asteroid itself showed no signs of biological activity, its raw materials offer insights into the building blocks of life. Scientists realize that the more asteroids we study, the closer we come to understanding the conditions that led to the emergence of life on Earth. The success of the first landing also encourages private companies to begin investing in space technology. Entrepreneurs develop new propulsion systems, new robotic assistants, new mining mechanisms, and new habitat modules designed to withstand microgravity and radiation. The private sector sees opportunities not just in resource extraction, but in transportation science, tourism, and deep space logistics. Entire industries emerge around preparing humanity for sustained activity among the asteroids. This economic expansion accelerates technological innovation and drives down the cost of access to space, making exploration more feasible for future generations. As humanity looks forward, new plans take shape for extended stays on asteroids. Scientists propose constructing inflatable habitats that anchor to the surface using sophisticated gripping systems capable of adapting to uneven terrain. These habitats would provide safe working environments for long-term study. Furthermore, engineers explore the idea of establishing small domed laboratories that could rotate slowly to simulate partial gravity. Such advancements could allow researchers to live on asteroids for weeks or months analyzing material and performing experiments that cannot be conducted from orbit. The appeal of asteroids grows as their strategic value becomes clearer. They could serve as fueling stations, supply depots, and transfer points for missions to Mars and beyond. Their resources could support the construction of spacecraft without requiring heavy materials to be launched from Earth. Some asteroids contain metals that could build structures in space. Others carry water ice that could be converted into fuel. Humanity begins to understand that the solar system itself may hold everything needed to sustain a thriving civilization. The first asteroid landing becomes the spark that reveals this possibility. Psychologists and sociologists continue studying the astronauts who completed the mission. They examine how prolonged exposure to isolation, microgravity, and cosmic silence affects cognitive and emotional well-being. They analyze how astronauts cope with the sight of Earth shrinking into the distance, and how they adapt to the surreal experience of standing on a tiny rock suspended in infinite blackness. These studies will inform the training of future explorers, preparing them for the intense mental challenges that accompany deep space missions. The emotional resilience demonstrated by the first crew becomes a benchmark for future selection processes. The astronauts themselves become ambassadors of exploration. They travel the world, sharing their experiences with students, scientists, leaders, and the general public. Their stories hold a unique power as they describe moments of silence, vulnerability, and discovery. They explain how the asteroid mission changed their perspective on life and how it deepened their appreciation for Earth and humanity. Their accounts bring the experience closer to millions who may never leave Earth, but still feel connected to the cosmic journey. The mission becomes not only a scientific milestone, but a shared emotional experience. Over time, the asteroid on which humans first landed gains a symbolic identity. It becomes known as a birthplace of cosmic exploration, a site where humanity demonstrated its readiness to expand beyond familiar boundaries. Astronomers observe it regularly, and space agencies track its orbit with reverence, recognizing it as a landmark of human achievement. Future missions occasionally pass nearby, capturing new images that show the tiny signs of human presence still preserved on its surface. These images remind people of the moment humanity first reached beyond its cradle. Centuries later, the asteroid continues to influence the direction of exploration. Its samples remain vital references for research. Its data continues guiding mission planning. Its story continues inspiring explorers. Even as humanity establishes cities on Mars, research stations on Europa, and mining operations among the asteroid belt, the memory of the first landing remains a foundational chapter in the greater story of human expansion. Humanity eventually becomes a multi-world species, but that evolution always traces back to the moment when humans first stepped onto an asteroid. The mission symbolizes the courage to confront the unknown, the persistence to overcome challenges and the imagination to envision a future not limited by the boundaries of one world. It stands as a testament to the ability of human beings to transform dreams into reality one step at a time. And as the centuries unfold, as humans travel deeper into the solar system, and perhaps beyond, they carry with them the spirit of that first landing. They carry the knowledge that even the smallest steps can echo through eternity. They carry the reminder that the universe is vast, but not unreachable. And they carry the understanding that exploration is not a destination, but a continuous journey driven by curiosity, courage, and hope.